Thank you all for joining. Welcome to InRhythm Lightning Talks. I'm your host, Parag Katkar. I'm the head of consulting practices at InRhythm, and we have a lot of exciting lightning talks lined up for you. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time, and each week, one of our consultants shares their knowledge on the latest trends in the industry. And today, Odion Edwards, who is a software engineer with us, is going to give an overview of SystemLynx JS, which is a framework for developing modular web APIs in Node.js. He himself has built this framework, so I'm looking forward to learn more about it. Without further ado, let's get it started, Odion.
Hi, guys. My name is Odion Edwards. I'm a software engineer here at InRhythm. Currently, I'm working at MasterCard. So again, yeah, this is SystemLynx is a framework that I developed myself. So I'm like super excited to tell you guys about it. So let's get right into it. So what is SystemLynx? So SystemLynx is a framework for developing modular web APIs in Node.js. So in my experience as a Node.js developer, there are not many backend frameworks that offer a similar kind of modularity that we get from frameworks like React and Angular. So basically, that's the initial thought that sparked the idea for SystemLynx. So SystemLynx is an agile solution for the complexity of microservices software systems. It's an object-oriented, it's an object-oriented approach to web API development. It comes with System View. System View is a graphical interface for creating and documenting documentation and tests that run across multiple services. And SystemLynx lives up to its namesake. It's swift, it's agile, it's flexible, and connected. So let's talk about some of the challenges we face when developing microservices software systems using REST. So the first one is complexity. So developing a system with independent services will increase complexity as each service must manage its own communication between other services. So the more services you add to your system, the more endpoints you have to create, more complexity. So lack of bidirectional communication is another limitation of REST that is actually a crucial aspect of developing microservices software systems. Monitoring and testing is a big challenge with microservices software systems, as each service can be running remotely in separate environments, and also services must be able to discover each other. So also, I added this quote. I actually got this quote from a previous lightning talk on GraphQL that was done by Paul Pladzewicz. So, and I think he got it from the GraphQL team. So it says, we don't think of data in terms of in terms of resource URLs. We think about it in terms of objects and the classes we ultimately use in our apps. So basically, I took this quote, I altered it a little bit, because while GraphQL is focused on returning data from queries, SystemLynx is focused on downloading functionality from the service into the client application. So why SystemLynx? So SystemLynx is built on top of Express.js and Socket.io. And even though it incorporates these two libraries in a way that allows you to not have to think about client-server communication, it still allows you to have access to these libraries if you want to extend functionality further. So if you're familiar with Express, as most of us are, and Socket.io, then you should love SystemLynx. So SystemLynx philosophy and motivation. So the motivation behind SystemLynx was to abstract away client-server communication. SystemLynx is focused on software system development versus app development. I feel like libraries like Express, just focused on developing a web app, while SystemLynx is, in its approach, is thinking about different components in a system working together. So simplicity is another focus, simplicity and boilerplate. For example, when we develop Express servers, we install Express, then we install JSON parser, then we install Malter, then we configure all that. So basically, SystemLynx has a basic setup that's has you ready to develop systems. SystemLynx is about extensibility through plugins and about modular JavaScript. So let's get more into the framework. In the next section, I'm going to go over an introduction of SystemLynx, talk about the difference between a SystemLynx service and a client, how to emit and receive events in SystemLynx, what a SystemLynx app is, and how it all works under the system. And finally, we'll take a look at system view, testing and documentation, and a demo. SystemLynx is an NPM module, so it can be installed using npm install SystemLynx. So this is a snippet from the README. SystemLynx is a Node.js framework for building modular web APIs built on top of Express and Socket.io. It allows you to create objects and load them from a server into a client application. So SystemLynx comes with the following objects that are used for web API development. So we have an app, service, client, and load balancer. So the service is used to create and host objects that can be loaded and used by a SystemLynx client. The client is used in the client application to load a service, providing access to all the objects hosted by the service. And app provides a modular interface for creating and loading services. So here's an example of a SystemLynx service and client. So we have a SystemLynx service example on the left, in which you can see that we're importing the SystemLynx in its service. We're defining a route port host, creating an object, and adding a method to that object. And finally, we are calling service.module, passing a name for the object and the object itself as the second parameter. And once we call start service, service.start service with the route port and host, the service is ready to interact with a remote client. So on the client side, you can see that we are importing the SystemLynx client, and we're simply calling client.loadService, passing in the service URL, and now we have a handle on the user module that was created remotely in the back end. So yeah, we can simply call any method that was created on that service and get the results it returns. So that's the simplicity of SystemLynx. So in this next example, it features the same code snippets from the previous slide, but you can see that we've added a line of code for the service. We're within the context of the add function, we can call this.emit to emit an event. We're emitting the new user event here, and we can see that on the client side now, we are listening for a new user event with the user.on method. Okay. So finally, here we have an example of a SystemLynx app. And this is actually a software system that I'm working on myself right now. This is a basketball app that I'm creating, and this would be the back end for it. So right here, you can see that this is just importing different objects, AKA modules, that are eventually going to be exported. And we're just defining route port, host, and use REST options. So one thing about SystemLynx is, even though it doesn't use REST, it's RESTable. So, and what I mean by that is, if you pass use REST true as an option to the start service method, it will automatically create a RESTful route for any object with a method called get, put, post, delete, etc. So for example, if you create an object, for example, user.get, and use REST is true, then you can also make a GET request and use the query parameters to pass an object. So that's one cool thing about SystemLynx. You can develop your software systems thinking about objects, and at the same time, if you need to expose a particular endpoint, you can easily do that. So yeah, but yeah, before I move on, we just notice that the app is a bit different from the service and the client, and the fact that each method called on the app will return the app itself, so you can chain methods. And also we have lifecycle events. This is an example of a lifecycle event that you can listen to. Life cycle events are very useful because you can use it to, there are different life cycle events that you can use for logs, to create logs, to respond to errors, and for authentication. But we're not going to get into that today. So how it all works. So basically you can make a GET request to the service URL, and it will return what we call connection data. And connection data basically has an array of modules, and each module has some information that's useful to the SystemLynx client for making requests. So this is actually another method that exists on the SystemLynx client. If you already have a connection data, instead of calling load service, you can just call create service and get a handle on the service. So that's how it works. So now let's talk about system view. So system view, what is system view? System view is a SystemLynx plugin. It's a CLI tool, and it's a graphical interface for documenting and testing your services. So it's also an NPM package, so you can install it. Running npm install system view globally. So here's an example of a code snippet of using the SystemLynx plugin. So as you can see, this is the same code snippet from the previous example, but we've just added basically 2 lines. Right here, we're importing this system view plugin. It's a method, it's a function rather, and we're calling that function with a few options. The connection tells us where the system view plugin is currently running, so that it can connect to it. Specs is locally where you want to save your test and documentation. Service ID will be the unique name for each service within a project, and a project code is a code that identifies multiple services that are part of one project. So after defining the plugin, you can just use system view, and there you go, you're connected to system view. So in the next slide, we're going to get into a demonstration of system view and SystemLynx, but for now, I just want to tell you some of the benefits. So system view basically uses a scratch pad for testing, for running tests across multiple services. So, and the benefits of this are like tests are easy to read and understand. So yeah, tests can be created in seconds. Tests can be automatically generated and updated according to changes. I mean, documentation can be automatically updated and created and updated based on change in tests. Unit tests can run across multiple services, and just in general, systematic documentation will lead to faster onboarding. And we all know onboarding is one of the toughest challenges of any project. So finally, we've reached the SystemLynx and system view demo. I hope you guys will enjoy. Let's get into it. Okay, so let's get into the demo. So this is an example of a software system that I'm developing using SystemLynx. In fact, this is the same code that you might recognize from the previous slide. So the relevant part for now, for the demo is, again, the here where I'm connecting to system view. I'm indicating a folder where I want to save my test and documentation. And you can see this is where my test and documentation is being saved by system view. I indicate a project code that indicates which project I'm working on and the service ID to identify the service. So if I go to my localhost 3000 where I have system view running, I can search the project code and I can pull up a representation of all the objects, the services, and all the objects that are currently a part of this project. So currently you see I have 2 services as a part of this project. This is actually the service URL where which will return the connection data. So again, in the basketball service, we have all these different objects. And basically, again, this is just a demonstration of a depiction of the software system you're working on, the service you're working on. So these icons indicate whether you already have test or documentation saved. So for example, if I click here where there's no documentation saved and I start writing some documentation and save it, you'll see that this shows that I have documentation saved. And also, and a new file was saved locally. If I delete this, no more documentation icon, and the documentation was deleted locally. But yeah, let me just kind of show you some documentations that I already filled out for different parts of my system. But actually, I just have a lot of test documentation filled in here just to show you how things look. And again, you can edit this documentation from this window and it will update whatever you change locally. So now this is where we come over to the scratch pad where we can, again, create tests and save those tests and rerun those tests in the future. So for example, this, I can simply click this button to run a test. It just basically call this method. And since I didn't add any arguments, it just responded with an error from SystemLynx. So you can also add different arguments to your test, and you can also add different actions that can happen in sequence before the test. This is the main section, and you can add actions, events, and actions that happened after the test. So again, here's an example of some saved tests. I can run these tests at any time. Just show you an example of tests that return errors so you can see what that looks like. And yeah, basically, there's a lot more to this and I can go on forever, but I think I'm gonna wrap this demonstration up with this. Thank you for listening. So with that demo complete, so is my talk. So I'm gonna open this up for questions.
Hey, Odion.
Yeah.
Awesome to see, a framework that you made yourself. I was wondering what made you choose the name SystemLynx, like links?
Okay, that's a good question. Actually, I'm not sure if some of you guys remember when I first started and I was, talking about this framework. I actually called it Task JS. Like I literally just came up with a random name for it because I've thought of this idea, but I didn't have a good name for years. So so yeah, it's actually recently, I actually, from time to time just brainstormed, and finally I came up with a name that I looked for to see if there are other packages that exist. I definitely wanted to, SystemLynx definitely express, it captures completely what the framework's about. It's about developing systems, and it's about making it easy for these systems to link and communicate with each other. So a lynx is actually a cat. So my ideal logo is like a image of a cat that's a depiction of a system at the same time. But yeah. Any other questions?
Hey, Odion. Just a really quick thing. Can I see one of those generated tests that comes out of the system view?
Sure.
What the code looks like?
Yep. So yeah. Oh, this is actually the demo. So yeah. So look, I can just run it. I can run a test just by clicking this button. It's basically gonna call this method under the hood. When you have a test, you have the results, which since I'm not passing the right arguments, it's just going to respond with a result. It's actually probably not being handled, or maybe it is status 400, so probably it's being handled.
Well, I guess my question was like, does this code get generated into like a unit test inside of your code? And is that, can you just open that up in an IDE?
So yeah, so basically this is where the code, the documentation and the test are saved locally. So the tests are basically JSON files that I save as TXT, because NodeMon is watching for JSON files and will continually reload your app if I programmatically save JSON files for you. So I just save it as a TXT file and parse it. So basically the tests are just saved as instructions that are in the form of JSON. I can even literally show you what a test looks like in the console. I'm like a kid. I'm like a kid right now. So yeah, this is just an example of the test, and this is literally what a test is. It's just instructions for each namespace. So what was returned was an error, and there's like a different namespace for each error. So yeah, that's basically the same thing I was going to show you here actually, which would be more relevant. Sorry, one sec. So yeah, so as soon as you run a test, you automatically have, as soon as you execute a function and it returns an object, you have a test. It is automatically testing for the types. So you can change the types, and it's going to show you have an error. You can also expand this, and you can add, for example, if this is a string, you can add string equals or minimum length and maximum length, and so on and so forth. So each one of these have like different types, have a different, you have other tests that you can add. So yeah, once you save these tests, actually it needs you to put a name in for you to save the test. Once you save the test, you could just rerun them locally. I save them with errors, so they show errors. You can delete tests. And again, what I would have loved to talk about more is, again, just how cool it is. You can add actions that happen before the test. And you can actually target information that's returned from a previous test, because when we're running tests, the way we write tests now, sometimes we have to set up mocks. Sometimes we have to do actions that happen before the test. So I'm running through this really fast, but yeah, I have even tools. This is like a fully comprehensive testing suite that's made from a scratch pad.
And how do you run all the tests if you needed to?
So yeah, you can run, if you have a bunch of saved tests, for example, I'm sorry, just closing this. When you have a bunch of saved tests, you can just come down to where to save tests and click this button. This is all the tests being ran right here. It's showing that all these tests passed. I have some saved tests right here that have some errors. So yeah, again, so the tests are very simple. You have a method that's called, and you have arguments. This one doesn't have any arguments. So, basically it just, when the response is returned, it evaluates the response. And you can save different validations for each response. So I guess this test only has 3 validations. These 2 are failing. So yeah.
All right, thank you. Thank you.
Good questions, guys. Any other questions? All right. Thank you so much, Odion. Excellent talk. Thank you. And as a reminder to you all, we do these talks every Thursday at 5:15 p.m. Eastern Time. And next week, Miles Dixon, who is a tech lead with us, is going to give us an overview of Babylon JS. Babylon JS is a really powerful web-based 3D graphics engine that allows the users to have a full-featured engine that can run on a browser. I'm really looking forward to this talk. Make sure you mark your calendar for next week. Thank you all once again for joining, and have a wonderful evening. I'll see you all next week.